RBS Business Research Academy welcomes you in the lecture number 45. This is the part of the series of the higher constructs in the SmartPLS. So in this video lecture number 45, we are understanding that how we can measure the reflective higher order constructs. So there are the two parts of this video. In the theoretical part, I have discussed the concept of the reflective and the formative, and how the reflective is different from the formative, and how we can, what we can measure when our both, like that means the higher order construct and the lower order construct, both are reflective and reflective. And in the second part of the practical part of this video, I have discussed that how we can measure the relative and reflective hydro construct in the smart video. So let's start our this video. So before this one, my name is Dr. Rahim Sumuru, and I'm working as a professor at HTMT University, Pakistan. So here is a wonderful paper which I strongly recommend you please go through this one, sir, because whatever the videos I have prepared on the higher order constructs, so mainly I have referred this research paper. Its name is How to Specify, Estimate, Validated Higher Order Construct, which is written by the Marcus Sardes, Joseph Hare, Ju Hua, and Jen Michael Baker and Chris Ringel. So these are very famous professors of the SmartPLS are there. So that's why I strongly recommend to this web. So its link of this research paper I have also left below this video. So if you are interested, you can also download this paper from the given link. So what is the difference between the reflective and the formative? Here, this like the PPT will give you the concept. The various reflective indicators are essentially interchangeable, and that therefore removal of the item does not change the essential nature of the underlying factor. So basically what happened is that in the reflective, normally basically we are asking the one thing to the different questions. So are through the different items. If the one item you are deleting, then the rest of the items are there. So in this way, the overall the nature of the construct will not be changed. Whereas in case of the format, you're looking here, omitting indicated omitting the part of the construct. So when we talk about the formative, in the one formative construct, there are the different like the parts are there. So if you are deleting or omitting any one indicator, any one question, that means you are deleting the when complete part of this construct. So how, and in the next slide I will show you. But before this one, if we talk about the overlapping, then you're looking here in the formative measurement, it tries to minimize the overlapping. So you're looking here that the minimize the overlapping is very small in this one. Where in the formative, it tries to have a more overlapping. So here you're looking at the construct are highly more overlapped with each other in comparison to the formative measurement model. So that's why we can say that if we are reading the any one like the item from the reflective, it has nothing to do with the health of the overall construct. But if you are reading one item from the formative, then it is a big impact on the like the overall the image of the formative construct. So here furthermore, this is one construct which we call as a formative. This construct is a reflective. So here looking, restaurant had attractive interior design and decoration. So here we talk about the design and decoration. Here we are talking about the background music. Here we are talking about the clean lineness of the dining area of the restaurant. And here we're talking about the employees' need and well dressed. So here we, and overall we can say that by going through this whole construct, that the every item is talking about the a different like the aspect of our like the restaurant. In case of the farm reflective, here looking that the food was delicious, food was nutritious, and the restaurant offered fresh food, and food was enticing, and the presentation of food was visually very attractive. So that means that here by going through all these items, you are reaching on this conclusion that we are seeing the same thing but in the different question. So therefore here we can observe the much more overlapping, and here we observe that there is less overlapping. But overlapping is important. So overlapping will always be there, because overlapping other terms we can call it's a correlation. So whenever there is no correlation between the two items, you cannot regress these two. So one more example is about the reflective. I feel the hotel is I feel well in this hotel. I always happy to stay in this hotel. I recommend this hotel to others. So now, if now these three items are there, and these three items are basically talking about the hotel. If you read any one item, for them, if this one it's had nothing to do with the others one. Others are there, and through this one you can also ask the same thing regarding the hotel. And in the format you're looking here, the service is good, personnel is friendly, and the room is very. So now here we are seeing the different is different aspect of the hotel in the different questions. So if you're reading this one, it has a big impact on the overall the like the health of this constructs. So this is another example about the difference between the reflective and the formative. So when you talk about the reflective specification, so first thing is a repeated indicator approach. So in the reflective, you're looking at the unidimensionality and the interchangeably. So now in the last slide, you have gone through that in the reflective, we were talking about only one dimension. So all the items were interchangeably. If you delete one item, it had nothing to do with the others, because the same still the dimension is there. And the first law on the repeated indicator approach. So in the repeated indicators, what we have to do, we have to assign the reflective measurement model of the higher construct. So simultaneously, whatever the these are the items. So now what we have to assign these items to the this higher order construct in the reflective in the repeated indicator approach. And then we have to measure like the antecedent construct are directly related to the higher order construct. So now these constructs these items are directly now related with the higher order construct, these constructs. And then next one. So here in the first we focus the measurement model of the assessment. So first we have to focus on the measurement model. So when we are going to evaluate any construct in the SmartPLS, there are the two models are there. One is a measurement model and other is a structural model. So right now we talk about the measurement model. So assessment of the measurement model is basically assessment of the reliability and the validity. So in this regard, first we have to assess the lower order construct, and then we have to there assess their discriminatory validity of the all the construct of the lower order. And then we have to apply disjoint approach in the first stage. We have to estimate the we in the first stage like the stage create and estimate the model connecting all lower order construct with the components. Okay, and here including exogenous and the endogenous, like the independent variable and the dependent variable. In the model assessment, first we have to focus on the reflective measurement model of the lower order, and the second stage we have to take their latent variable score. So when we take the latent variable score, then what will happen is we have another data set in our SmartPLS-4. In the disjoint approach, again, for this purpose, locate the score of the LOCs, of the HOCs, and then add a new variable to the data set. And in this regard, we have to add new variables. So now previously we were working on the other independent variable, but after getting the scores of the lower order and higher order construct, now we have to work on this data set, and whatever the variables are there, now we have to assign these new independent variables with the higher order construct, and then we have to use the repeated indicator approach over there. So in there's a disjoint approach, evolution of the two stage. Stage 2 start with the focusing on the reflective measurement model of the higher order component, and then we have to assess the CR and the AVE of the loading of the all indicators and the AVE. And then we have to check the critical value of the point like the 0.05 along with the Cronbach alpha composite reliability and the AVE of the all the reflectively measured construct variable. And then we have to work on the based on HTMT criterion discriminant validity. We have to check these HTMT and discriminant validity. And finally, we have to work on the structural model. As already I told you that there are the two models, structural model and the measurement model. So now here in the structural model, what we have to check? So we have to check the significance of relevant path, Q square and PLS predict. These things we have to measure in the part of the structural model. So here one exhibit is there like this one, systematic evolution of the PLS-SEM result. So here first we have to check the evolution of the measure model. So we have the two measurement model. One is a reflective and another is a formative. So as we are working on the reflective measurement model, so therefore we have nothing to do with the formative right now in this video. So what we have to check? We have to check internal consistency through the composite reliability. We have to check the indicator reliability. We have to check the convergent validity through the AVE, and then lastly we have to check the discriminant validity in the measurement model. When you talk about the structural model, what we have to check? We have to check the R square, Q square, path coefficient, and effect size, H square, and then we have to check the effect size of the Q square. So these are the normally benchmark which we have to check when we are working on the structural model, and these are some of the benchmark which you have to check when we are working on the measurement model. So here we are now going to the practical part of this video in the SmartPLS. So now we are the practical part of this video. Here you are looking at one research model on the SmartPLS-4. In this we are looking here, all are our reflective latent variable, because the arrow is pointing from the latent variable to its indicator. So that's why we can say all our latent variable are reflective. So now we have to check their validity and the reliability. So now what we have to do, just go into the one more thing which I want to. So here we are checking the reliability without our higher order construct. So another model is there. This is the with the higher order constructs. So, but before this one, we want to apply the measurement, like the measurement of the validity and reliability without the higher order construct, to check that either all these respectively measured variable are reliable and validate or not. So that's very simple. Just go PLS algorithm and apply all these one. So here, just we have to go on the construct, validity and the reliability. So here we have the some results are there. Construct reliability overview. Here we have the Cronbach alpha, and then composite reliability row A, C, and the AVE average variance extracted. So how to understand? But before this one, here is a one table exhibit 4.10. This one is a rule of thumb for evaluating reflective measurement model. So whenever we have to evaluate the reflective measurement model, then we have to check these things, and along with these benchmarks are there. First one is the internal consistency and the indicator reliability. So these two are measures of the reliability, whereas the validity, the convergent validity, we can check through the AVE, and the discriminant validity, which we can check through the Fronell-Larcker criterion and the HTMT. So now in order to check the validity, we have the three criterion. First one is a AVE, and then another one is a Fronell-Larcker criterion, and the third one is a HTMT. While to check the validity or reliability, we have the two internal consistency of the construct and the indicators reliability. Indicators means one question of the every construct. So these things. So first of all, internal consistency of the. So now if the the value is a 0.7 or above, then we can say that the reliability through the Cronbach alpha is intact, because it is 0.7 and above. And in some cases, in case of expert research, okay, if it's less than 0.7 and up to the 0.6, it's a considerable, but not less than the 0.6. And indicator reliability is if this value is a 0.7 or more, then we should say that this indicator is reliable. But in some cases, if the value is less than 0.7 to 0.4, and if we remove this indicator from the construct, if we have no impact, then we should keep it with its construct. And because you know that when we are working on the reflective model, so reflective models are basically a unidimensional model are there. So in this way, we are asking the several questions to measure a one dimension. You are looking here one image where we are where we want to check the the food quality with the help of the several questions. So whatever questions are in the food quality, all are basically talking about the only one dimension. So that's why that if we are removing any one indicator from the construct, it has nothing to do with the, or it has no negative impact on the overall reliability of the construct, or of the meaning of the construct, because all the questions are basically mirroring the same dimension. And now, if we talk about this one, that the Cronbach alpha of the network says orientation, all they are well below, well above to the 0.7. And then compose reliability, again, this one also 0.7, and the AV is also above 0.5. So now all the values are in our green color, so we must be happy. The beauty of this software means the SmartPLS is that whenever there is any violation, the violation will be shown to you with the help of the red color. The value will be in the red color. So all our values are in green color. So we should be happy with this one. But practically, this is case may not be with you. Whenever you want to analyze the data, some of the values may be in the red colors, and some of the values may be in the green color. So whenever any value is in the red colors, it is thing that means you should go and check the indicator. For example, here, so now these are indicators. If any indicator's value is less than 0.7, then you should consider to delete it. When you will delete it, okay, one more thing. So again, I have to apply this one. Okay, okay. So when you are deleting any indicator, if it's by deleting this indicator, if the value of the Cronbach alpha, compose reliability, or AV is increased, then you can delete it. But its value should be less than 0.7. So now, if you achieve all the values are in green color, so now then there is no need to remove any indicator from any construct. But any indicator, its value is even less than 0.4, then you should consider is to delete it from your analysis. And then, okay, one more thing then. So you should delete the indicator one by one. Delete one indicator and apply the algorithm and see the results. How much change is in the positive change is in the overall the values of your Cronbach alpha, compose reliability, and AV. Once if you are achieving all the values are within the benchmark, then do not consider to delete any indicator. And then discriminability in this one. So first one is a heterotrait, monotrait. So what is heterotrait and monotrait? It is basically the HTMT is based on the estimation of the correlation between the construct discriminability is established based on the HTMT ratio. So now here means a discriminability. It means how one your construct is different from the another one. Now, for example, up to what level interval skill is different from the interval competence, interval performance is different from the market orientation. So now this is called the discriminability. And HTMT, however, there should be the threshold for has been debated in the existing literature, because the different researchers have a different opinion about the threshold of the HTMT. So, however, two thresholds are here. One is a client who said in 2011 that the suggested the 0.8 are less. Then if this is a value, then we must be happy that the HTMT or discriminability with the help of the HTMT has been intacted. And other two et al. In the 2008, he's of the opinion that if the value is even more than 0.9 less than 0.9, so now again our HTMT has been intacted. So these two values are there. Whatever criterion we follow, either 0.9 or 0.85, our values are well below this one. So now HTMT, which is the first criterion of the discriminability, has been established. And another one is the Fronell-Larcker criterion. Now it is about the, according to the Fronell-Larcker criterion 1981 criterion, discriminability is established when the square root of the AV is greater than its correlation with all other constructs. So all these are the constructs. These are the concepts. Now this is the table of the correlation. So now here we want to correlate the interval competence with the interval skill, interval competence with the interval performance, interval competence with the sales orientation, and with all others one. So all these are the values of this one. But here, so this value 0.89. How we have achieved this 0.89? We have achieved this value through the AVE. For example, this one is a AVE 0.79. So if this is a 0.79, if we take its square root, so it is a 0.888. So now here, this is if you round up the 0.888, it will become the 0.89. Another value, for example, sales orientation is there. So sales orientation is AVE is 0.8. So if we measure 0.8 square root, it's a 8944. 8944, and then so now again sales orientation is a almost, if you round up to this the same, it will become the 0.9. So now these values are basically the square root of our AVEs. So AVEs, these are our AVEs. If you take the square root of all AVEs, we will get these values must be greater than in this column. So all these columns. So now this 0.89, you are witnessing that this one is above then all these one. 0.84 is above all these one in the same way. And the last is the cross loading. So cross loading here. So in order to understand the cross loading, what we have to do that we have to copy, and then we go on the Excel, and then we have to paste here. So now if we paste, the first one is our input competencies. If you color it, then I check that all these are horizontally, so are much higher than rest of these values are there. Let me say this loading. So now if you compare this loading with all these are much higher. So now it means that through this one, the first construct interval competencies, the discriminant validity through the cross loading has been established. And another input skill you're looking here, again we are giving it another color. So now this one is right or left, that one is higher than the values which are around it. And then interval performance, then again check their values are also higher left or right. In the same way, if we go here, market orientation. So in the market orientation here, so again in the market orientation, again you are finding the same case is with the market orientation. And then another one is a network. Network has also the same case over here. And last that one is a sales orientation. Sales orientation has also the same. So that means all the values are above with across with the other loadings in the of the same construct in the horizontally. So from this point of view, we can say that all our loadings are means this loadings, that means cross loadings, they are above than their like the counterpart loadings of the different constructs. So here we can say that the discriminant validity, so here we can say that the validity and the reliability of the all reflectively measured latent variable have been measured, and all are within the range. Okay, are within the range, are above than whatever benchmarks are there. And then now we are going to check the validity and reliability of the higher order construct. How to achieve? Then again, that's very easy. In order to work on the higher order construct, first we have to compute the latent score. How to compute? Just create the data file, and here looking in this way we can compute the latent variable score of the manifest variable and the latent variable. And then if you press create, then it will create in the data file. And now we are going on with the higher order construct. So how? So in this one, you're looking the data set. Now we have the two data set. One is the data for reflective, and it is the data set for the data for reflective higher order construct right from the PLS-SEM results. So this is the data set on which we have to work right now. So here these are our lower order constructs. So their reliability and validity already we have established, and now we have to check the validity and reliability of the higher order construct. So in this one, if you go in this one and show the indicators, so these indicators are there. So basically these indicators are not of its own, but these indicators are in the like the product indicator approach. So now we assign all these indicators repeated indicator approach. So according to the repeated indicator approach, all the indicator from here we assign to all these ones. So that's why these are not indicators of itself. So now that's why we want to check the higher order constructs reliability, validity, but not with this one. We have to remove all these like the indicators, because these are not of its own. And then how to do this one? That's very simple. And then you select all these one and delete from here, and then also delete here. So then you're looking here at the end, we have received some of Latent score variable in this one, interval competence here. That's okay. Interval skills, okay. And then market orientation and the sales orientation. So now these are the 4 items are there, and then we have to shorten it because they are very long. Latent variable score, delete it and apply. Then next one, delete the latent variable score and apply. Then again delete the latent variable and apply. And the last one, okay, market oriented, and then sales orientation and delete. And then this one is also there, and now our all the values have been shortened, and then we have to connect with this one and then this one. And now we should apply our algorithm on this one. So same algorithm, and then so first off, consider reliability. You are looking here, AV is fine. So one more thing, that the already the reliability and validity of the interval performance and network already we have checked, and that and has been established. So now we have to check only the reliability and validity of the interval competence. So here, okay, so in this one now here, so AV is fine, it is above the 0.5 CRA and the CRC, both are good. That's just a very little problem, and insignificant problem is with the Cronbach alpha, because 0.69 is almost round off, it's the 0.7. So now generally we can say that we have achieved this result. Now why this one is 0.69? This is because of this one. You look then this one is less than 0.7. If you delete this one, then hopefully that okay, for example, you delete it, and then again if we are repeating the same one, and then you look at the okay, again the problem is there. There's by deleting this one, this item even has been decreased. So now we attach this one, and then again we have to check its reliability. So now if we delete it, then there is no benefit, but overall we can say that the Cronbach alpha is a 0.7. So all the benchmarks of the customer reliability and the validity, like the Cronbach alpha, composite reliability, and EV are established. Okay, so now if we want to measure the risk validity, the first one is a heterotrade, monotrade. Again, these are within our range. And Fronell-Larcker criterion, these are ours. And then see the AVE of the square root of the AV is higher in this column. This one is higher on column, and obviously is higher. And cross loading, then again these cross loadings are good for AV. So in this say, that means that we have been checked the reliability and the validity of the second order. This is our second order latent variable, and all are intact, all are established. So now we have to check the effect of our bootstrapping. So through the bootstrapping, in the graphical output is there, and path coefficient are there. So here all are significant, and total indirect specific indirect effect is also significant. This p value, and then if we okay, r square path value, and now these are, so now these are the path and their significance values all are okay, all are within the range. So in this way, along with the very good r squares are there 0.38 and the 0.24. So in this way, we have checked the reliability and the validity of the lower order construct and the higher order construct. So I hope this video has cleared your several concepts or confusions regarding the how to evaluate the reliability and validity of the higher order construct and lower order construct. If it is so, you are requested to subscribe my channel, to like this video and share the video with the rest of the people. Thank you very much for watching this video.